Hello there, Coach Reza. My name is Owen Beatty, student number 101379668, and this will be my submission for assignment 2, albeit very late, and I apologize for that. That being said, let me jump right into it. So, first, after reading all of this information, we will be inputting the iris.csv set, which I grabbed and put over here. It will be read from pandas, as always. We will go ahead and read it, and then show the head, and that will be the end of steps 0 and 1. So as we can see, we've properly imported. Next, we will be turning the strings from the different types of flowers into their respective either 0, 1, or 2 to help the networks work later on. So, as we can see, we will be changing each species name to a different integer, and then mapping that to the iris data set. And as we can see, now species is 0. So then, moving on, we will be grabbing the first 4 columns, which will be the original, all the original data. So as we can see, we grab it, I printed it just to show that it worked properly, setting it as X, and then grabbing the newly changed types of flowers and reading that as Y. As we can see, it's changed 0 and 2, and 1 is in there, but just in the middle section there. So now, number 4, we will be splitting all of it into into the X train test, Y train test, using the random state 1, 2, 3, just to make sure that every answer is similar to the rest of the class, which makes a lot of sense. So we will check the head of all of them to make sure that they worked properly. As we can see, they did. So split based on 0.2, so the test will be 20% of it, randomly split. And there we go. We can see 130, 130, 119, 119, 72. Oh, sorry about that. 72, 72, and 112, 112. So it's been split the same way among each set. And here we will be checking the length. It's 120 and 30, just like mentioned here, which is awesome. So now we'll actually get into the fun part of the assignment. We will be first encoding the changed different types into a categorical, which this process was difficult for me, and I had to spend a reasonable amount of time researching, and because I ran into a ton of problems, but at the end of the day, even with these warnings, it ended up working properly. I got some problems with, it wasn't reading the size of my one-hot sets properly before. But at this point in the assignment, I do have it working. So we will make the first of 2 different neural networks here. We will be using 100 size here, which we'll see a vast difference in the 10 size that we use later on. We will have 2 different layers of ReLU type, and then 1 of softmax, the softmax being the finisher one, just like assignment 1. And then we can go ahead and compile it. Again, this is very similar to assignment 1, but I do really appreciate the goal of this assignment being to really show the difference in how different sizes and different networks change how the results come out differently at the end. So, sorry, I'm getting ahead of myself. Right here, we will be fitting the first data with 20 different epochs in batch size 10, and as we can see, the loss and accuracy significantly improved from 99 to 11 and 61 to 97.5, so 98 pretty much by the end. As we can see, that follows over to these test loss and accuracy evaluations here. Now we will be making the second of the two, which really show the difference in how the different network sizes and shapes will really change the outputs. So as you can see, we run a 10 size neural network as opposed or layer into this neural network as opposed to 100, and also doing only 4 epochs. We can see the loss in accuracy is significantly different by the end. I'm not. I would want to do some further research into why and how it's above 1. But just on the first pass through, that's how it ended up, which is a little bit shocking to me. Pardon me. And also, once again, we end at 20% as opposed to 96 up here, which we can really see the difference, and it really makes you appreciate how different the sizes of the networks can really change the outputs. So here, I just went over basically what I've spoken through as the entire assignment, as I was talking through the assignment in general. And then I jumped into my different tests moving forward from this set here. So even though we have a size 10 network, and that's what we're using here, putting it through another 100 epochs, it still manages to around, I think as I mentioned here in my overfitting question, around number 50, we can see a significant drop in the change in accuracy. So even here in let's just go from the top. So from around epoch 9 here, we're at lost 97% and 47% accuracy. And then 10 epochs after that, like epoch 20, we can see that we've already cut that in half and pretty much gotten to a very good accuracy value. And then specifically once we reach around epoch 50, the significant drops in loss and increases in accuracy become noticeably smaller and smaller and smaller, which can possibly indicate that we are getting closer to a potential of overfitting. And in a more complicated data set than Iris, we could absolutely be getting to a point where our model is working against us. And I did a few more epochs with a smaller batch size just as a test, which that actually significantly got the loss further down. So that would actually be something I would also like to look into moving forward. But that will be all. I really, really appreciate the opportunity to catch up on this assignment, and it really makes it easy, or it really helps me move forward with the course in a healthy way, because everything's piling up, and I'd just like to say thank you. So thank you very much, Coach Reza. I do not plan to be this late on assignment 3. So yeah, thank you very much, and I'll see you Tuesday morning. Goodbye.